You writing something story?
No,
Oh, okay.
I should, right?
Yeah.
Alright, so, what do you remember?
Nothing.
What was the net distance or the displacement?
Shut up.
The distance from my starting point to my ending point, right? Okay, now when we did that section, we called it net distance for the most part, and that's why we had to put the absolute value around it, because we were considering it to be only positive, right? Once you call it displacement, then it changes to what we call a vector, and vectors can have magnitude and direction, so they can be negative, okay? So today, when we find displacement, okay, your answers could be negative. That just means that you were moving more in one direction than you were in the other. That's why you ended up in that place or in that position. You understand? Yeah? Right? And we're going to use the velocity function, and we're going to actually integrate that velocity function to spit out the position function and be able to calculate that displacement and that total distance. Right? Now the difference between the two is that total distance has to be what? Positive, right? So I have to take into consideration the areas or the spaces where the particle changed direction. Okay? Because if you change direction, then I'm going to get a negative velocity, right? Okay? And then that part of the graph is going to be below the curve. Okay? And when I find that space bounded by the curve, it's going to be a negative amount of space. So I have to imagine that that negative space is what? Positive when I'm looking for the total distance traveled. Okay? So if you remember the velocity curve, when we're finding an integral, we're finding the integral of a rate. What we're calculating is the net change of whatever it was that rate was describing. So if the rate is describing the rate at which I'm pouring water into a tank, okay? So let's say it's cubic feet per minute. When I integrate that from a certain time interval to a certain time, it's going to calculate the amount of water only, the cubic feet of water that I poured into the tank in that time interval. Okay, and if you think about it, when we did the Riemann sums, what were we multiplying? So let's say I'm doing cubic feet per minute. I'm describing the rate at which I'm pouring something into a container. Yes? So it's volume per minute. And we had some curve. If I wanted to do a Riemann sum, I would make a rectangle, right?
Yeah.
So I would be multiplying what units? The width, which is minutes, right? Times the height, which is what? Cubic feet per minute. So what happens to the minutes? They cancel out, right? So it shows you how much water has accumulated in that particular time interval. Understand? Same thing if we're talking about velocity, right? So velocity is a rate of change of position, right? So it'll be like feet per what? Per minute or per second or whatever, right? And if we integrate that over a certain time interval, it's telling me how much feet, right? How much distance has accumulated, right? In that particular time interval. Do you understand it? Yeah? We'll look at more of what the meaning of the integral is tomorrow, but today the main thing is just to understand how to set up my integral if I'm looking for displacement, how to set up my integral if I'm looking for total distance. Okay? Sounds good? Alright, let's go through it. It's really easy. And it's kind of easy to remember the formulas if you remember that total distance has to be what? Positive. So what can I do to something if I want it to always be positive?
Absolute value.
Take the absolute value of it, right? That's exactly what we'll do in the integration formula. Alright, so let's start off with what it says here at the beginning. Okay? We know that if I integrate the velocity function, its antiderivative should be the what?
Position.
The position function, right? So it should be P of X, or P of T, I'm sorry, evaluated from A to B. And if I evaluated P of T from A to B, I say P of B, right? Minus P of A, using the fundamental theorem of what? Of calculus, right? Good? Or if I had F prime there, its antiderivative would be F, right? If I had F double prime, its antiderivative would be F prime. Those were the way we presented the problems before we left for spring break, right? Okay, now we're gonna try to relate them to particle motion. So, if I'm looking for the displacement of the particle from on some interval, all I have to do is integrate that velocity function. What it's going to do is it's going to calculate the bounded space between the curve, right? So it's going to calculate the bounded space between the curve and the x-axis. So this is when the particle is moving to the right, right? Then this is when it was moving to the left, and then this is when it was moving to the right. So it's figuring out how much it moved to the right, how much it moved to the left, how much it moved to the right, and it's doing what with those? It's combining them, right? And it's not taking into consideration that that part down there is negative, right? So it's putting it there together there as a negative. So it's calculating how much it moved to the left. So your answer might end up being a negative number. Is that okay?
Yes.
Can displacement be negative?
Yes.
Very good. I got one of my kids this Saturday. They were talking about the vertical displacement of a trigonometric function, and he didn't consider it to be negative. He said it was vertically displaced 5 units when it should have been negative 5 units because it moved down, and that messed them up. Yep. But anyways, life lesson, right? Rookie mistake. Okay. So now notice that it also says this: if v of t is greater than 0, that means the velocity is what? If the velocity is positive on that interval, it also represents the what? The total distance, right? Why is it that it cannot be when it's less than 0 all the time?
When it's positive, it's zero.
Because I thought we said that displacement was equal to total distance as long as it was only moving in one direction. Right? Isn't that what we said?
Yeah.
So why wouldn't it work here? If velocity was always less than 0, that means it was always moving to the left in one direction. Why wouldn't that work?
Because total distance can't be negative.
Displacement can be negative. But not total distance? Right, because then we'd have a part of the graph that was always where? Underneath the curve, so when I do that integral, I'm going to get a what kind of answer? A negative answer, right? And I can't have that because I need it to be total distance. What could I do to that negative answer?
Absolute value.
Just make it positive, right? Okay, but they don't want to put that, so they only consider it if the velocity is greater than 0. In other words, if the graph of the velocity function is always above the x-axis, then you can say that displacement is equal to total distance. Okay, but theoretically, if I'm only moving in one direction, okay, displacement is equal to total distance. It just won't work here with the integral. This will not spit out the total distance even though you're only moving to the left, because you're getting a negative number. You just have to remember to make that positive. Okay? Do you understand? Maybe? Sort of? Kind of? Alright, so how do we fix that? Okay, the next one is asking for total distance. We know total distance has to be what? Must be positive. Okay? So that's what's going to help you remember what you got to do to the velocity, okay? What do I have to do to it to make it always positive? Get the absolute value, right? And what do we call the absolute value of velocity?
The speed.
Speed, okay? So it is the speed. So when you integrate the speed, okay, you'll figure out the total distance. So what would happen to this graph, if I got the absolute value of it, is this part right here that's negative would end up being what? Positive, right? It would reflect over the x-axis, and therefore I would find the total distance. Okay? That's what happens when you get the absolute value of a function on the graph. Any part that was negative becomes positive. Alright? So notice it says here, to be safe, always do this integral when asked to find the total what? The total distance. So if you're not sure whether it changes directions or whether it's always positive, just do this anyways. So that way you make sure that you're getting the right answer. Most of the time they'll ask this question on the calculator section. So, I mean, all you have to do is type it in with the absolute value, put the equation in there, and boom, it'll spit out the answer, and you'll be okay. Okay? Do some practice problems? The main thing from the lesson is to understand the difference in the formulas and how to set up the integrals. Everything else on the notes is going to be like review. Problems where we're reviewing things that we've done in the past. Good?
Yes, sir.
Alright, so let's jump into it, okay? It says the velocity of a particle is moving along the x-axis is given by this function. Okay, this is a non-calculator question. So what can you tell me about this graph?
It's continuous.
It's always positive, so it's a parabola, right? That moved what? 6 units up. Is it opening up or opening down? It's opening up, right? So if it's opening up and it's 6 units up, is it ever going to be negative? No, so we know that the velocity is always what? Very good. Okay, so we can write that down. V of t is greater than 0, right? Only moves to the right. So it doesn't matter what interval I choose. No. What can we say is equal to what? So displacement is equal to total distance, right? Because the velocity is greater than 0. Good? Alright, so let's keep reading. If the position of the particle at t equals 4 is 72, what is the position at 2? Okay, so ask yourself, what is it that they want me to find? What are they asking me to find? Position when t equals 2, so that's p of 2. Do I have anything having to do with p here? No. I have the velocity, right? But I know that if I do what to velocity, I'll get the position function. Integrate it, right? So I know that I need to set up an integral, okay? I also know that p of what? 4 is 72, right? So can I set up an integral that will spit out something, an equation that has p of 4 and p of 2? Yeah? Alright, can you tell me what that integral would be? Integral of v of t, okay? dt, from where to where? From 2 to 4, very good. Small to big, right? Or left to right. And what would that end up equaling? P of 4 minus P of 2, beautiful. This will be on your quiz that's upcoming. This is stuff that we did before we left for the break, right? Okay, we know P of 4 is what? So we know 72 minus P of 2 and is equal to what? We got to figure out this. Okay, so we know what V of t is. We know V of t is 3t squared plus 6. Can I find its antiderivative and then apply the fundamental theorem of calculus? Right, what's the antiderivative? T cubed plus 6t. And we're going to evaluate it from 2 to what? 2 to 4. So remember, we plug in the upper limit. 4 to the third plus 6 times 4. Minus, plug in the bottom limit. 2 to the third plus 6 times 2. And that should equal 72 minus p of 2. So 4 to the third, 64 plus 24? 88, 2 to the third, that's 8, plus 12, 20, 88 take away 20, 68 equals 72 minus P of 2. So 72 take away what gives you 68? 4. P of 2 is 4. What would the units be if there were units here? Like let's say the velocity was feet per second. This would just be feet, right? Okay, because it's a position, it's a location. Got it? Alright, not too bad. Part B says, what is the total distance that the particle travels from 0 to 7? What could we do there?
Evaluate the thing, integral from 0 to 7.
Very good, we could do the same integral, right? But instead of from 2 to 4, now it would be from 0 to 7. Do we need to put the absolute value on it? No, why not? Because velocity in this problem is always what? Greater than 0, right? So that's the one thing. Okay? Don't think of it as like it's always moving just in one direction, because that won't work. If it was always moving to the left, it wouldn't happen here. Okay? Good? So that we can put, since V of t is greater than 0, right?